Space telescopes allow us to observe the vast universe. But NASA believes our current equipment is due for an upgrade. The James Webb Space Telescope is the successor to the aging Hubble Space Telescope. It's the most advanced piece of observational equipment ever built. So what secrets will we be able to discover with it? Using its massive gold-coated mirrors, scientists hope to observe exoplanets in the vicinity of our solar system and find planets that are potentially habitable. The new space telescope will also allow scientists to observe what our universe was like as far back as 250 million years after the Big Bang. Space telescopes are especially suited for these tasks for two primary reasons: their design and location. Let's start with their design. Telescopes are able to zoom in on an object by gathering and focusing light into their viewfinder. For refracting telescopes, the light from a distant object coming in parallel rays is focused through special curved pieces of glass called lenses, which function as a telescope's optics. Once the light passes through, the gathered focused light produces an image in the telescope's viewfinder. You can just imagine how big the lenses would have to be on space telescopes. That's why space telescopes are designed to use mirrors instead of lenses. In fact, most large-scale telescopes you'll find on observatories around the world use mirrors too. There are a few reasons for this. One is practicality. Bigger, heavier lenses are required to see objects further away. If the objects are light years away, you would need to construct massive, incredibly thick lenses. By utilizing mirrors, engineers require far less glass in the construction of space telescopes. This reduced amount of glass then leads to an overall decrease in the weight of the space telescope, making it easier to launch into space. Another reason why mirrors are used in space instead of lenses is reliability. The thicker a lens gets, the less light passes through, leading to a darker image. In space, where light is relatively scarce, this could render a telescope useless. Aside from that, even the slightest amount of damage on the surface of a lens could distort the image entirely, as lenses need to be perfectly smooth to maintain the fidelity of the image. So now you might be wondering, why do people even bother launching telescopes into space in the first place? As powerful as telescopes on the ground are, they're limited in functionality. This is due to the Earth's atmosphere. Certain wavelengths of light do not readily pass through the atmosphere. This is certainly good for keeping life on Earth safe from cosmic radiation, but it's a huge problem for anyone performing any kind of astronomical research. Atmospheric distortion from light traveling through different densities and pockets of turbulence in the air layers can also obscure images produced by planet-side telescopes. The turbulence makes the stars twinkle in the sky to the naked eye. While this is good for poets, it is not as helpful for astronomers. Placing telescopes in space also opens up new modes of astronomical research altogether. While most space telescopes like the Hubble are designed to primarily capture and view visible light, some space telescopes are a bit more specialized in nature. For example, the XMM Newton was built for a specific purpose, to observe and detect X-ray waves. The Earth's atmosphere makes this impossible to do on the ground, as it blocks these incredibly high-energy waves from passing through. In space, however, it's fair game. X-ray telescopes like the XMM Newton are able to observe objects up to 100 million Kelvin in temperature. When objects reach these temperatures, they begin to emit X-rays, which are strong enough to penetrate the mirrors of a normal space telescope. X-ray telescopes prevent this from happening by arranging their mirrors in specially placed tubes. This allows X-ray waves to simply skim across the surfaces of the mirrors, much like a rock would across a pond, and onto a detector. Space telescopes are crucial tools to aid us in deepening our understanding of the universe, so space programs all around the world have launched these incredibly expensive pieces of technology into space. Even with the launch of the James Webb Space Telescope, NASA, JAXA, and CNSA still have plans to deploy more of these research devices into orbit. Some scientists even foresee a need to build a new series of great observatories that could cost up to $11 billion each to construct. With so many mysteries in the universe waiting to be discovered, that cost is not too great in the grander scheme of things.